Let's try with the linear regression. We're going to copy the data again into a new sheet and call this linear regression. LinReg. First of all, because we've got to make the linear regression, which means we got to make room for it. So we're going to insert a column here. And we're basically going to call this one. This is going to be our x-axis. So just call x2, and these we can just drag down. And then we do have a nice counter. We're going for data analysis, linear regression. Input for y area is of course our containers. Input for x area is our counter. And we got the labels in the first row. Don't worry about the residual plot. We're just going to run it and see here we've got the parameters. P-value. It explains 52% of the changes. The p-value are both significant. And here are our coefficients, the cutoff point and our x. So let's copy those and go back to our linreg. Here we are. We're just going to put these here. Now we can create our prediction, which is of course the x multiplied by the slope. We're going to log the slope because we're going to copy it, and we're going to add the intercept and also log that one. Now we can just copy it. I'm going to use a few less decimals. Just copy it down. So we can have a look at the prediction. Let's see what it looks like. Just going to make 2 lines of this. Insert line plot. This is what it looks like. Our prediction goes very nicely in between the data in the data, which looks fine. It seems if data follows it. Let's have a look at our residuals. These are basically our residuals. What we're going to do is we're going to get our residuals, which is of course the difference between what we see, between our observations and our prediction. This is these two deducted. And let's have a look at our residuals. These are the ones we want to be stationary. So let's have a insert line plot for these two and see if they're stationary. They're going a little bit down, but it seems as if the variance seems the same. And if we look, the mean should sort of goes up and down a little bit, but the mean should be all right here. We're going to worry about the peaks afterwards. Now we're just going to make a few checks for the model. We want the error, we want the squared error. We want the MAD, and we want the residual squared. The MAD is just the absolute value, ABS, of the residual. Again, a bit fewer here. And the residual squared equals the residual squared. The square thing emphasizes large deviations. And let's have a look at the here. We're going to take the sum of the residuals. See what happens. Should be close to 0 because that is the whole point of the linear regression, that the residuals are 0. Then we're going to take the sum of the MAD, which is the absolute deviations, the auto sum here, 117, and we got 44 observations, and we wanted to have the average, mean absolute deviation average of that is 2.67, and we're going to add everything up here too of the squared, and we're going to divide that by 44, and we're going to take the square root of that, which means basically this is also our standard deviation. That's an S too much in the start here, so square root. Why we do that? Square root. Let's take the sum. Just take the sum of everything here, and divide that by 44. And we're going to take the square root. Of course, in Danish is koviol. That's the problem. Koviol. So, and divided by 44, of course. And we see that the square root, the variance the standard deviation is a bit bigger than the MAD, almost one higher, and we see some heavy deviations up here. But these are our comparison values when we are looking at the other models. So basically, it follows very nicely. It's more or less stationary, and these are our baseline to compare.